Welcome to this week's Unikernel application spotlight. This week we are looking at ArkFlow. I guess I've been on a data streaming kick the past couple of months. We've been looking at a lot of projects in the space. I just feel stream processing engines and stuff is actually a really good fit for unikernels. Typically, these you want low latency, you want high throughput. Um, you don't really want to deal with the mess of some of the older portions of this ecosystem where you have to stand up 20 different daemons. I really like these simple ones where you have one application running and it just does its task. So ArkFlow is right there, in that domain. So real quick, if you haven't watched any of the other videos or if you don't really know the space very well, basically data streaming is just the idea that you typically there are many applications where you want to collect data as it arrives, processes it, and then move it on its way. Versus like something like a SQL, traditional OLAP SQL where you run a query, you get the result, and then maybe you stuff it into a web page or whatever. This is kind of continuously querying, continuously operating on the data live as it exists. You run a query and it doesn't actually end; it just keeps running. So yeah, this is built in Rust. It's has quite a few different sources and sinks and so forth. So its inputs, you can generate, and we're going to show you the generation example. HTTP, Kafka, MQTT. I should mention both Kafka and MQTT and SQL and stuff. You'll find quite a few different packages on the ops package repository. We can just search for, well, there should be an MQTT. Maybe it's there's a couple of them in there. I'm not finding them immediately. Here's some Kafka ones. Anyways, I'm gonna have to look into that. Then you got your processors. Obviously, JSON, Euro, SQL. You could do protobufs. So protobufs are pretty big in the Go world. So if you're coming from there, then chances are you're dealing with it in your projects there. You got your sinks, same thing, ship it out. In this example, we're just going to do a standard out, so you can kind of get the feel of things. And then, the various SQL queries, they got this nifty little deploy guide, but I'm going to actually show you how to deploy this on a Unikernel, not Kubernetes. It's just easier. So this is the repo. I think I saw this on, like most of these projects, I see them on HN, and then I'm like, oh, let's run it as a Unikernel. Pretty self-explanatory, getting started instructions. This is the actual quick start we're going to do. As you can kind of see, basically you have this generation input where it's just generating a bunch of temperature readings. And then we're going to throw it into this pipe and then query it. And that's what we're going to do. So we can, this is the little package that I made. Now I stuffed this config into sysroot. What you might do instead, and I almost debated about doing this because I think in real life, you probably wouldn't stuff this in here. Like, I mean, if it's static, it would make sense to put the config in here if this config is not changing that much. But, maybe it just belongs as an optional configuration that you set when you're creating this. I guess it depends on how you're going to deploy it. It's important to note that packages can take configuration in addition to the configuration that they already have. So it's really, 6 or half a dozen the other. It doesn't really matter. But yeah, for this, I just chose to stuff it in there. As you can see, there's not really anything in this package. It's just the libraries that it needs, and that's it. So, yeah, let's just show it to you real quick. So we're gonna load it up, and it immediately starts, and you can kind of see the output here. I'm gonna pause this for a second. If we go up here, you can see this processor worker. And when I first saw this, I was like, crap, I'm gonna have to like patch this or something. But that's actually not the case because it's using Tokyo, and I don't purport to be a Tokyo, know much about it, or even Rust for that matter. But I can find my way around things. And so if we look at the source, we can kind of see what it's actually using underneath. So ArkFlow source. ArkFlow core source mod. Source stream mod. If I can read. 39. Yeah, so you look at this processor work. I think this is just kind of named weirdly because if you look at what's actually calling this do processor, it's doing this tracker spawn. So if we go up to tracker, you can see this is a part of Tokyo, and we go over to Tokyo, find out what these tasks are. Turns out Tokyo tasks are just asynchronous green threads. What that really means is it's essentially you can go ahead and stick a block of code into these tasks, and then they'll execute later on. Green threads mean that they don't actually match one-to-one to an actual OS thread. They can, but that's not what they really mean. So Go routines, for instance, in Golang, they're also considered green threads. Erlang has concept of green threads. Java even now has the concept of green threads. So it's actually, I feel like it's a good model. There's obviously a lot of debate in the world about async in general, but I'm not going to wade into that. So, anyways, this is the workhorse of how it's actually running these. So even though this says kind of processor, it's not a process. Anyways, this was a quick little example of how you can run ArkFlow as a Nanos Unikernel. Till next time.